Algebra 2 students, in our new lesson we're going to be learning how to use the quadratic formula to solve quadratic equations. Before we can do that, I'm going to show you where the quadratic formula comes from. So here on the right hand side of the screen is the quadratic formula. If I'm trying to solve a quadratic equation where ax squared plus bx plus c is equal to 0, the solutions would be found using the quadratic formula, and they would be equal to the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Now again, this formula works for any and all quadratic equations as long as they're put into standard form and I use the numbers correctly. Now, understanding that they're just letters at the moment, but I'm going to show you where this quadratic equation or quadratic formula comes from. So we're going to solve this equation with a, b, and c instead of numbers. We're going to solve it by completing the square. Here we go. When solving by completing the square, my first step is to make sure that the first term is simply x squared. So to make that happen, I have to divide the entire equation by a, the leading coefficient. That will leave me with x squared plus b over a times x plus c over a equals 0. Dividing 0 by anything remains 0. Next step in completing the square is I need to make room for the box, as we call it. So we'll subtract the constant term at the end from both sides, which will leave us with x squared plus b over a times x on the left. And again, this will leave room for the box, the value that will complete our square. On the other side, we have the opposite of c over a. And we'll also add the box because we're going to go ahead and be fair all the time in algebra. Now, the tricky part is, with what do we fill in the box? Well, our trick was always to take the middle term, whatever it was, and cut it in half. So b divided by a cut in half. Well, cutting something in half is the same thing as multiplying it by 1/2. So I'm going to show you what that looks like. If I multiply by this by 1/2, I end up with b over 2a. Now, in order to fill in the box, what I do is I take that value and I square it. So I'll go ahead and square this expression. Now, when you square a fraction, you square both the numerator. So that'll be b squared. And you square the denominator, both parts of it. So 2 squared is 4, a squared is a squared. So we have b squared over 4a squared. Doesn't quite fit in the box, but it'll be okay. Same thing goes in this box, b squared over 4a squared. Now the left side of my equation has now become a perfect square trinomial because I have completed the square. So my next step is to rewrite it as the square of a binomial. Well, if you remember how this works, x is going to be the first term. The second term in my binomial will be the thing that I got when I cut the middle term in half. So b over 2a is going to go right here, b over 2a. And it was a positive term in the beginning, so I'll put a plus sign right here. Now this is equal to, on the other side, I've got these two expressions here. Well, both of these are fractions and they have a different denominator. Now, if I wanted to add two fractions together, such as, I don't know, 2/3 plus 1/6, I'd have to have a common denominator. So the least common denominator in this case, between 3 and 6, the least common denominator is the least common factor of 3 and 6. Well, that's 6. So I'm going to change this by multiplying by 2 over 2. So I do that because I'm multiplying 2 over 2 is the same as 1, and 2 times 3 is 6. So now I've got 4 over 6 plus 1 over 6. I add them together, I get 5/6. So you get the idea. I'm going to use that property now to add these two fractions together. The least common denominator of these two fractions is going to be 4a squared. So I want my other denominator to look like this. Well, what's it missing? Well, it's got one a, but it's missing a 4, and it's missing another a. So I'm going to go ahead and multiply this by 4a, and I'll multiply the top and the bottom by 4a, because 4a times a is 4a squared. And in my numerator, I now have negative c times 4, well, it's negative 4 times a times c. And I'm adding b squared over that same fraction, 4a squared. Well, now that they have the same denominator like these did when I have 4/6 plus 1/6, I add the numerators together and I write that common denominator. Let's add the numerators together. B squared plus negative 4ac. I'm going to go ahead and write it that way. I'm just going to turn the order around. And if you peek at the quadratic formula, you might see why I'm changing the order. So b squared minus 4ac, all over the same denominator, which happens to be 4a squared. So at this point, we're pretty close to solving and getting our quadratic formula. I'm going to make some room by erasing this fraction. And I'm going to go ahead and copy these and move them up here. Again, so we can see what our finished product is about to look like. Now, I'm solving for x. Remember, that's the whole goal with completing the squares, to get x by itself. So now that I have a square, my next step is to take the square root of both sides. When I take the square root of both sides, that's when the plus or minus symbol comes out. I also can take the square root of the numerator divided by the square root of the denominator. Well, the square root of the denominator, the square root of 4a squared, is 2a. No square root symbol required, because the square root of 4 is 2 and the square root of a squared is 8. It's just 2a. So my square root symbol is now only in the numerator. The left side, all I did was get rid of the square. So I have x plus b over 2a. And that's equal to this expression we have on the right. So my final step in completing the square to solve an equation is to get x by itself. Well, that means I'm going to go ahead and subtract the b over 2a from both sides. Now when I write this, I'm going to put it in front, because if you'll notice, I have the same fraction denominator, 2a, which means I can combine the numerators. And guess what x is equal to? X is now by itself, and it's equal to the opposite of b, plus or minus the square root of b squared minus 4ac all over, remember, it's the same denominator. I can combine the numerators and write it over one denominator, 2a. And that is the quadratic formula that you see right up here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And we'll look at how to apply that in just a moment.